Hello and welcome to another tutorial. We're going to continue our discussion on how to use JNI in combination with the native image. We saw that we can just quickly set up a simple class that has a static method which is native, say hi, and then we got the header file, we implemented it in C++, we compiled the C++ to a dynamic library, and we use system.load to load that dynamic library using the absolute path. But now obviously if we run the native image we're going to fail. But what we can do is, first of all, that dynamic library has just some binaries, right? So what we can do, native image compiler allows us to define any file as a resource, and then it picks up all the binaries, zeros and ones, and embed them into the final executable file. So that's what we're going to do. But because this dynamic library for our JNI calls is some file on the operating system, we have to tell the native image that, hey, we are using some resources outside the JDK, which means we have to run the JVM that comes with the GraalVM and activate the agent so that it can pick up on all the resources and JNI calls, and it automatically creates this meta-inf /native image. We just have to make sure that wherever we put these directories and all the files that are inside this directory are on the class path, so that the native image compiler automatically picks up on these extra configurations, right? So, and we saw this in the past, how to correctly do this. So after development of the JNI, getting a dynamic library, the next step is to make sure that we run the Java agent and get these configurations. And then the other thing is that so far we saw that we just use system.load and use the absolute path to the file. When we are compiling to native binaries, we can embed the dynamic library in the form of binaries in our executable file. Native image can do that. But then this absolute path to the file is not going to work anymore, right? System.load does not support loading binaries as input stream, because we saw that in the previous lectures where we talked about resources and embedding them in the native image in the executable. We saw that we can always open up a binary input or input stream, a byte stream to the resources that are embedded in the native image. But then we cannot pass a input stream directly to the system.load, right? We can't even pass, let's say, even a file input stream there. So you have to give it just some file that already exists. And so how do we do this? We put the dynamic library on the class path as a resource at compile time. And then we load this, or we search for this resource at runtime using a platform independent method, which we saw it. We use the class loader, and then the class loader is part of the JVM. At runtime, JVM knows what the directories are included in the class path. So this makes the whole stuff independent of file system of the host that runs our application. And then we open a binary input stream to dynamic lib that is embedded in the native image. Now we have to pull out all those binaries and put them together as a file on the host operating system. That's the whole point, right? Copy the binaries into an actual file on the file system of the host. And after we do that, and it's very easy to do it in Java. Java already has very nice APIs. And after we copy or pull out all those binaries as a separate file, now we can create a file object and pass it or give it to the system.load. And optionally, we can also ask the JVM to delete the copied file when the Java process or the application terminates, right? So if you look at here, we said that the platform independent way of loading a resource at runtime is to make sure that it's part of our class path. It's inside a directory that is on the class path, and then we ask the class loader to get a system resource, or you can ask it to directly search for the resource and give you an input stream or a byte stream to that. Right now we're just asking it to get the system resource. Let's say this is our dynamic library, and then we get a URL to it, right? And then what we're going to do, we're going to ask this URL to open a stream, which gives us an input stream, which we can read all the bytes from that. And then we use the files class, which is a utility class in Java NIO, and do a copy. So we read all the bytes and we get a path. So we decide where to put this copy. So let's say we want to, wherever the native executable file is running, wherever the working directory is, we want to copy or pull out all those binaries of that dynamic library and put it in the same directory. with this name, right? Whatever name. And after these copies, we know that now we have a file on the file system of the host with whatever name we decided in the current working directory. So we can create a file object, which is our dynamic library, and then system.load, we get the absolute path to it, right? Because remember, system.load, you have to give it the absolute path to the file. And then we can also optionally ask JVM to delete this file that we created by pulling out all the binaries that were inside our native image. Normally we don't want to do that. I mean, because you can either ask the user at some point when at the beginning of running the application to decide where to, for example, save these files. Let's say most likely we want to put it somewhere in a directory on the user's home directory. But there's also an option to just delete on exit. So every time the user runs the application, we pull the binaries out, we create and copy the dynamic library, load it, and after that it terminates. Now obviously if the dynamic library is a very large file, this approach is not very efficient. So ideally you want to pull the binaries only the very first time that somebody runs the application, and then cache this file, right? Because this file obviously inside the native image, so its contents are not going to change. The user is just going to run the application. So eventually we want to ideally cache this file. The very first time somebody runs the application, we pull out all the binaries, save it as a file, and then cache it for future use, right? All right, so this is the entire concept. And once you get a grasp on how this works, we saw that same story happens for Java resources like text file, right? We embed everything. A scanner was a very nice class because you could directly give it a input stream, so that there is no problem with the embedding. For the system.load, we cannot do that. We cannot give it an input stream. So you have to pull the binaries out manually, copy them, create a file on the host operating system, and then give it to the system.load. So let's head to Eclipse and try to look at it. So this was our example. And if you recall, we create our C++ project. We compile it, we got the dynamic library, we put it on the src directory, which is on the class path. So it gets copied into the bin directory as well. Any file that is inside the src is a resource that will be copied by Eclipse into the bin directory as well. And we saw that in this JNI demo, if we run this, everything looks fine. Yes. And instead of doing system.load, what we're going to do, we're going to comment this out and do a platform independent way, right? So what we're going to do, first of all, if I just get this code and compile it to the native executable file, let's say we run our Java trace on this and we get the meta-inf. If you look at it, let's say JNI config or resource config, we're not getting anything. So the fact that we're using system.load with an absolute file, the Java agent for GraalVM cannot pick up on the fact that we are using an external dynamic library as a resource, right? So if I run my native image, so JNI demo, and then run the native image, it's going to pick up on this meta-inf, but there is no information about the resources. So it's not going to, the native image compiler is not going to embed any extra binaries, right? This file, this dynamic library, its binary content is not going to be embedded in the final executable file. So let's wait until we get the native files. The compilation is almost done. It's inlining, and then the final compilation, and then the linking so that we get the final executable file. So almost done. Yeah, done. So if you refresh this and then open up a terminal here, what we will see is that if I say java native image.jni demo, now it works. Let's see, that's because, all right, so the reason is that obviously it now works only on the host operating system where this file exists, right? So this works only because this file exists, right? If I delete this, it's not going to work anymore because obviously this path, the absolute path, has been hard coded in our executable file. So if I now run it again, it's going to say that I couldn't find this absolute file, right? Users, desktop, and this, so because I deleted this. So that was not the platform independent way of including this JNI calls this dynamic library into our native executable file. Just because if this is directly tied to my like host where I develop this application, and therefore if I give this executable to somebody else, they're going to run into this exception because they're not going to have that exact directory hierarchy, right? So what we want to do ideally, so let me say edit or copy and paste that dynamic library again into our SRC to have it. And again, now that this file is there, the absolute path is valid. If we run our Java application, it's going to work, right? So this works fine, but again, what this means is that the application just searches for this absolute path and searches to see if there's a file there. So this is not a portable application. It's directly tied to my personal computer for now. So what are we going to do for this? What we're going to do, we are going to, first of all, let's delete the meta-inf. We are going to recreate it and empty this native directory. We're going to do a platform independent way of loading this resource, because we put this resource, which is dynamic library, in our SRC, which is on the class path, or basically the bin directory is on the class path, not the SRC. But whatever we put in the SRC, the Eclipse will copy it also in the bin directory. So these are in the bin directory, and the bin directory is on the class path. So we're going to ask the class loader to get system resource, and the name is going to be the name of our dynamic library. So it's like libjava underscore native image underscore c.dylib, right? Remember, this is at the top level of our bin directory, so we just give it the name. And this returns a basically URL, let's call it X, right, or resource. And after that, what we're going to do, we're going to tell it to, first of all, we can, if you look at the basically all the methods that this URL provides, get content, right, or get file. So we can also say system.load x.getFile. This still works, and this returns the absolute path. So if you run this, this should work fine. Yes, no problem. But then again, if we compile to native executable, it's not going to work, because when we embed, so this line of code loading using the class loader will embed the binary content of this dynamic library into our native executable file. So if we try to run this with our Java agent, Java trace agent from GraalVM, and look at the meta-inf resource config, now it picks up on this dynamic library, because we are searching something on the class path. So the JVM is aware of we are loading some extra resource. So the native image picks up on that. Now that the meta-inf has this resource config, if we compile this application with a native image, the binary contents of this dynamic library will be included. But then this line, the second line, x.getFile, will fail, because once the contents are included in the executable binary, this doesn't return, the absolute path that this returns is not going to be correct. So we cannot do this. What do? We go and try to extract the binary out of it. So let me just maybe also compile this, and so we have the meta-inf, the resource is configured. So let's do run compile again and see if it's going to work or not. So this time again, the binary contents of the dynamic library will be included in the final executable file. But the way that this line, the way we tell it to, okay, URL get file, this is going to fail, because once the contents are in the executable file, this x.get file will not return a valid path or valid file that is valid on the operating system, the host operating system, right? So the compilation is finished. Let's refresh this. Let's open our terminal here, and let's run this. And now it's going to can't load library. And you notice that x.get file says from the root go this. And remember, this root is actually referring to the native image, the file, but to the operating system, system.load maps to a file on the operating system. It means from the root of the host operating system. So this is not correct, right? So this doesn't work, even though we already have the binary content. So we have to pull out that binary content. So what we're going to say that, we're going to say, let's say file is, or let's call this dilib is new file. And we're going to give it exactly this name or whatever name that we wish, right? And we're going to say that we try to see if it's been cached or not. So let's say we want to cache it in the same working directory that we run our executable file. So if dilib.exists, we're not going to do something, and if it doesn't exist, we're going to not it. Then we're going to say that files.copy from the source. What is our source? We're going to actually use the copy method that takes the input stream, because now that all the binaries are inside our executable file, we can open up an input stream, right? So x.open_stream. Target is the directory. We have to give it a path. So paths.get, and the directory is going to be, I guess, the current directory. And then options, we're just going to say that there is the default option. And then we have to import this also paths from JavaNIO. And this is going to throw exceptions. So let's round it with try catch. So if dynamic library already exists, we're not going to do anything because it's already been cached. If it doesn't exist, so let's also print some comments. If dynamic library doesn't exist out, extracting the JNI dynamic library, right? And if else, if the dynamic library already exists, we're going to sys out using cached JNI dynamic library. And if the file already exists, we're going to just say that system dot load, and then dilib get absolute path, right? So we just feed it. And if it doesn't exist, then we're going to extract the binaries, copy them into, so we have to tell it, we also have to give it the name. So copy with some name. We're using the same name. You don't have to use the same name when you're extracting the file. So let's say we're going to say that mylib.dilib. I just want to show that this name doesn't have to be the name of the original file that was embedded in our binary. So we're just going to rename these. All right. Or we can also do, for example, a relative path here. That's fine. So once we copy this, we're going to basically that's it. So we actually can put, because after copying we're also going to load it, so we can eventually, either the file doesn't exist, in that case we extract the binaries as a file, right? Or if it exists, we just tell it that okay, the file exists, we're going to use cache it, and in both ways we're going to get the absolute path of the dynamic library. So let's see if this works. So let's run this. So extracting the JNI dynamic library, hello world from C++, right? And you see mylib.dilib what was extracted, and this is exactly the binaries that are inside our right now we're running the Java, so we haven't compiled yet, but the code still works because this is a completely platform independent way. Even you run it on top of the JVM, we read this original dynamic library, copy all its content to the working directory. What is the working directory? When I run the Java application inside the Eclipse, it automatically sets it to the root directory of the Java project. So I expect to see a mylib.dilib file inside exactly in the Java project. So let's run this. It works fine, and mylib.dilib here, and it was already there. So in the second run, it says using the cached JNI dynamic library, because we already copied the files out, copied all the binary out, right? So we cached it. So this works fine. So what we need to do now, we are going to first of all run our Java trace again, so that it knows what's going on. So meta-inf, native image, resource config, and it is still only picks up on this libjava native image .lib, which is correct. That's where we are actually loading a resource into the JVM. The rest is not something that is related to resource loading, because we already loaded the resource and now we're doing something with it, right? So now if I go ahead and compile my native application, native image, hopefully this time everything works fine. We get an executable file that has all the contents of this dynamic library, and it's fully portable. It's not reliant on any host operating system. Note that this is only portable as long as you're not linking to a specific dynamic library on the host operating system. In this simple hello world C++ application, I didn't link against any particular dynamic library that is on my operating system. It's a very simple thing that only relies on the standard library that comes with C++. All right, this finished. Let's refresh. Let's open up our terminal, and hopefully this time everything works fine. Extracting the JNI dynamic library, and we get the output call from C++. If we do a ls, you see that mylib.dylib is there, right? If I run the application again, it says using cached JNI dynamic library. It doesn't do the copying again because it doesn't make sense, right? We want to extract the binaries the very first time, cache it, and later on we want to use it again, right? Now, ideally, normally what you see is that usually the applications create dot directories or hidden directories inside the home directory of the user and copy these cached files into those directories. So we could also set it up to do it, but right now we're just copying or extracting these binaries and cache them in whatever working directory that the user is running this application from. And that's obviously not ideal, because if the user copies this executable to any other directory and run it, we have to do the caching again, which is not ideal. So the best approach is always create a hidden directory in the home directory of the user and then cache the files inside that directory, so that whenever the user runs the application from any other directory, you always refer to that home directory. So I hope you enjoyed this lecture and now have a very solid understanding of how to extract binaries from the final executable file and deal with them. So please stay tuned, and I'll see you in the next one.